Hello, my name is Andrew Vincent, and I will be your host during this presentation of the Dungeons & Dragons system, which was designed by the Senior Design 1 class here at Oklahoma State University. I will begin by giving a short overview of the D&D system and its purpose, and then I will introduce a few other members of the Senior Design team who will provide a more in-depth description of the individual systems involved in the game. The goal of this project was to create a fully interactive, live-action role-playing game utilizing the styles and rules of D&D. Building upon a traditional laser tag style system, we created a new statistics engine with a graphical user interface that implemented the D&D rules in addition to designing new hardware that adds greater functionality to the system. This new system is comprised of 4 distinct subsystems, which will be described in greater detail. The subsystems include the spellcasting glove, headgear, trap, and statistics engine. Now I would like to introduce Eric Hayworth, who will explain the features of the Dungeons & Dragons spellcasting glove.
The spellcasting glove we have developed adds not only functionality to the D&D system, but also an aesthetic touch that enhances the ambience of the game. We have integrated 22 LEDs into each glove. These LEDs are connected to a processor which is programmed to display a light pattern whenever a spell is cast by the player. Each spell has its own unique light pattern so that the player can visually verify which spell has been cast. In addition to the LEDs, the spell glove incorporates an audio system that plays sound whenever a spell is cast. The glove is programmed with a unique sound effect for each spell, but can also be reprogrammed by the user to play whatever sound sample the player would like. The spell glove also includes an LED driver which transmits spell data to other players when a spell is cast. The LED driver includes one narrow angle LED for point effect spells and one wide angle LED for area effect spells. Each LED has 16 selectable brightness levels which allow spells to be effective over different ranges. And this is the end of our demonstration of the spell glove for Dungeons & Dragons.
Now we will hear from Matt Bowser, who will explain the features of the D&D headgear. The headgear, which we have designed for D&D, receives incoming spell data and alerts players with both visual and audio effects. These events signify hit, critical hit, unconscious, and dead. This imperative function keeps players informed as to the condition of their character. IR sensors detect incoming spells. These spells are packaged by the HIU and sent to the statistics engine for processing. Once the effect has been determined, the headgear alerts the player if they are hit, critically hit, unconscious, or dead. There are 2 methods of alerting a player which event has occurred. The first method is a group of LEDs which light up in accord to which event has occurred. The second method of alerting a player an important event has occurred is an audio system. This system plays a distinct sound when a player is hit, critically hit, unconscious, or dead. And that is the end of our demonstration of the headgear for Dungeons & Dragons. Next, I would like to introduce Darren Turner, who will explain the features of the trap.
Traps which we designed for the D&D system work very much like the area effect spells in that they affect everybody within range. Radio frequency transceivers transmit trap effect data whenever the trap is triggered by a player. These transceivers have 30 selectable power levels which allow the range of the trap effects to be modified. The trap can be activated by either a touch sensor electrode on the trap or by connected tripwire. Once activated, trap effect data is transmitted at a pre-selected power level. Now we can push the button.
Me and my beautiful hat.
Plug them now, or should I ground these things?
Got it. Players may interact with the trap using two important features. The first feature is the query feature, which allows a player to send an RF signal to find out what the transmission power level of the radio is. The second feature is the disable feature, which allows the player to send an RF signal to disable the bomb, which will take a set amount of time to actually disable. And that is the end of our demonstration of the trap for the Dungeons & Dragons.
We will now hear from David Fritz, who will explain the features of the D&D statistics engine and graphical user interface.
The statistics engine controls the actual rules of the Dungeons & Dragons game, performing calculations and processing data received from other parts of the D&D system. The graphical user interface communicates essential data to the player, in addition to allowing the player to cast spells. When data is received from the headgear or trap, the statistics engine performs all necessary calculations, updates player statistics, and then returns any necessary status data to the headgear. The graphical user interface is used to allow the player to interact directly with the game. The GUI displays the player's current health as well as a list of spells that the player may cast by selecting the appropriate spell and pressing the cast button. The GUI also includes a status window which displays what spell and what effect that spell has on the player. Finally, the GUI has a hold indicator that notifies the player when they can cast a spell. The indicator turns red for a period of time once a spell has been cast, and then turns yellow to signal the player that their spell casting ability is about to return. And that's the end of our demonstration of the statistics engine and graphical user interface for Dungeons & Dragons.
In addition to the features that have been shown here, the D&D system which we have designed shows great promise for future expansion. Some of the features that could not be implemented during this semester include flex sensors, which will be integrated into the fingers of the spell glove, allowing players to cast spells simply by bending the appropriate fingers. Motion sensors can be added to the traps, which will cause them to be activated when a player is within a specified range of the trap. The statistics engine can be easily expanded to support more spells, higher player levels, and other D&D functionality. The graphical user interface can be modified to display more player information, such as experience, inventory, and wealth. As you can imagine, the system has enormous potential for continued development, and with proper funding and support, future senior design students at Oklahoma State University can make the D&D live-action role-playing system the new standard in interactive entertainment. I hope you have enjoyed our demonstration of this incredible system, and I thank you for your time and attention.